All right, guys, so this is your lesson on the sun, okay? So we are going to talk about what the sun does for Earth, how it can affect us. We'll talk about the temperature of the sun, and we'll talk about how the sun can hurt us and help us, okay? So do me a favor, go ahead in your notes. I want you to pause the video, and I want you to try and answer these questions as best you can, okay? That way you know what you already know, so we can talk about what we're adding to what you know, and you can kind of compare notes with what I'm teaching you today, okay? All right, so now that you've had a chance to pause the video and answer those questions in your notes, let's talk a little bit about these, okay? So you probably learned in elementary school that the sun gives plants all their energy, so the plants use sunlight and water to create all that stuff that they need to survive. They're using that to make their food, and they also use that to make oxygen for us. So the sun gives us oxygen here on Earth. It makes it so the plants can give us oxygen. It makes the plants grow. And when the plants grow, all the animals and things that we eat on Earth, they also have things to eat. So the sun keeps us alive. It gives us all these things that we're able to eat. It also keeps us warm. That's another thing we need to know. We talk about how the sun keeps us warm, and we'll talk a little bit later on in our upcoming lessons about how the sun affects our seasons. Okay? All right. So how hot do you think the sun is? All right, so it depends on what part of the sun you're talking about. Some of them are only thousands of degrees. When I say only, I mean then relatively, because the sun is really hot. So in some places it's thousands of degrees Fahrenheit, and in some places it's millions of degrees Fahrenheit. And we'll talk about that in detail in the lesson. Okay, so the last question, can the sun hurt us as well as help us? Yes, of course the sun can hurt us. We've all had a sunburn or know somebody that's had a sunburn before, so that's an easy way to talk about the sun hurting us. And then we'll talk a little bit in this lesson about solar wind and how solar wind can affect us here on Earth, and that's sometimes a negative thing for us. Okay, so the title for your notes is the layers and parts of the sun, so if you want to add that to your notes, you can. And the first part of the sun we're going to talk about is the core. The core is the very center of the sun, calling the core of an apple is the center of that apple. Okay, so the core is around 27 million degrees Fahrenheit, and we know this because there's a bunch of fancy physicists and mathematicians that can look at the sun and see what's happening on the surface and give us an idea of about how hot it is in the very center. Now, in the very center of the sun, we have something special happening. It's called fusion. And fusion is what fuels the sun. So it uses that hydrogen and it fuses those atoms together and creates a whole lot of energy, and that's what runs the sun. Okay? So the sun's gravity produces all that heat and pressure down in the core, which causes the nuclear fusion to happen. Now, I've said nuclear fusion, but let's talk about what nuclear fusion actually is. So nuclear fusion is the fusing of atoms' nuclei, so the very center of that atom. They're fusing those together to create a new element, and this gives off a ton of energy, and that's what powers the sun. So that's why we can feel the sun's heat even from 93 million miles away. All right, now the photosphere is the surface of the sun. This is what we see when we look up at the sun, okay? It's around 10,000 degrees Fahrenheit. Different spaces will have different temperatures, especially some of the darker spots we see on the sun. Those will be a little bit cooler than the brighter areas, okay? Now, the sun's light comes from the photosphere, and an easy way to remember that is you need light to take a photograph, okay? So photo means light, so a photograph is a picture of the light that you can see. So the photosphere is where we see the sun's light coming from, okay? And it is giving off radiation, and that's what we see as the sunlight on Earth. Remember we talked about the electromagnetic spectrum is a bunch of different kinds of radiation. So visible light is a type of radiation, and that's what we see when we look up at the sun. We see that radiation as light here on Earth. All right, the next part is the corona. This is the sun's atmosphere. So just outside of the sun, just like Earth's atmosphere is just around the Earth, just outside of the Earth. So just outside of the surface of the sun is the corona, okay? Now, the temperature rises dramatically from the surface of the sun up to the corona. So the corona, the sun's atmosphere, is 3.5 million degrees Fahrenheit. Now, that's a roundabout number. It depends on different spaces, different areas. They could be slightly different temperatures. But the average temperature of the corona is 3.5 million degrees Fahrenheit. Okay? And we can only see this during a solar eclipse or with a special telescope. Okay? Now, Sunspots. We talked about this when we talked about the surface of the sun. These are cooler spots on the photosphere, okay? So these spots right here that are darker are a little bit cooler, and that's why they look darker, because all that heat and energy coming off of the sun is what makes it look really, really bright and creates all that light. So the areas that are darker, the areas that are cooler appear darker because they're not giving off as much energy, okay? All right, now, a prominence is a loop or a ring of hot gas spewing off of the photosphere. So it's coming off of the surface of the sun. Now, an easy way to remember that a prominence is a loop or a ring is to think about what prominence sounds like. Prominence sounds like promise. So when you get married or you want to propose to somebody, you're giving them that ring is a symbol of that promise, okay? So we can remember that a prominence is a loop or a ring, remembering that prominence sounds like the word promise, okay? Now, prominences increase the amount of solar wind coming off of the sun, so it's charged particles, it's kind of like static electricity, they're flying off of the sun, okay? So if there's a bunch of prominences on the surface of the sun, there's going to be more solar wind coming off of the sun. All right, the next part we're going to talk about is solar flares. Solar flares are explosions of gas coming from the photosphere, so they are coming from the surface of the sun. And solar flares, just like prominences, increase the amount of solar wind coming off of the sun. Okay, so now I've said solar wind a couple times. Let's talk about what that solar wind is and what it could look like to us here on Earth. All right, solar wind is a bunch of charged particles that are being blown off of the surface of the sun, and sometimes they're coming towards Earth, sometimes they are not coming towards us. So we are only on one side of the sun at any given time. So there's all the rest of the sun where things can be flying off of it. So that solar wind could be coming off of the opposite side of the sun from us, or it could be coming off the right side or the left side. But sometimes it's not pointed at Earth, and that's really, really fortunate for us because solar wind is like a giant shock of static electricity. And this energy can damage our satellites, our power grids, and even the cell phone towers here on Earth. So when we have a big solar storm, if it's pointed at Earth, it can knock out our satellites. That means we won't be able to use GPS. If it knocks out the power grid, that means our power is going to be out until they can fix that power grid. And if it's because of a solar storm, so when that solar wind makes it to Earth, we call it a solar storm. If it's because of a solar storm, they're going to have to go back and rebuild some of those parts. They're going to have to create things to fix it. So it is going to take a lot more time. All right, so if we have a major power outage because of a solar storm, then it's going to take a while for us to get our power back. Now, it depends on how bad that storm was. In some cases, it could be weeks or months that people are without power. Now, that hasn't happened to us in a while. It does happen sometimes, but for the most part, we haven't seen a bad solar storm here in a while. All right, and if it knocks down our cell phone towers, we will not be able to use our cell phones. We won't be able to make phone calls or send text messages, okay? So solar wind can cause a lot of issues for us. It can mess with all of our technology that we have here on Earth, okay? All right, so we talked about all these parts of the sun. Now, the sun is the largest and most massive object in our solar system, okay? So it is the largest object, and we are the closest to that large object, okay? It is about 93 million miles away from Earth. So even though it is the largest object that we are close to, it's still 93 million miles away from Earth, okay? And we do use this right here. We call that distance an astronomical unit, okay? So when somebody says, let's compare the distances in outer space, if we're using something that we know, we understand, a lot of times we'll use an astronomical unit or one distance from Earth to the sun. Okay, and now we talked about light years already in one of our previous lessons, but if we talk about how long it takes light to reach Earth coming from the sun, that's 8 minutes. Okay, so that one astronomical unit, or 93 million miles, is the same as 8 light minutes. Okay, and remember that is a distance. Even though it says minutes, we're talking about light minutes. Okay, and that changes it from a time measurement to a distance measurement. All right. So if the sun were to just completely go out or go dark, which is not really what it's going to do when it dies, but if it was to go completely dark, we wouldn't know for 8 minutes because there would still be that amount of light headed towards us, okay? So it would take us 8 minutes to realize that the sun has gone dark. All right, now let's talk about what these are. This is a list just so that your terms for all the parts of the sun are all in one spot. So these 6 are the same things that were already in your notes, and you are going to create a diagram of the sun, and I'll give you more directions on that later. Okay, so this is your notes for that lesson. So when you go to create your diagram of the sun, you're going to use these notes, and I've given you some examples down here at the bottom. Please be careful when you're looking at these. They are not all exactly the same. So this diagram does not have everything in the same spot as this diagram. Okay, so the sunspots are in different places, the solar flares and the prominences are in different places. So please make sure you're actually reading the diagram and being really careful when you're looking at the diagram. Make sure you're seeing the right parts in the right places. Okay? All right, so in your lesson, you'll use these as an example. I've got this one labeled right here. Okay, so we said the photosphere is the surface of the sun, so I'm just pointing to the surface of the sun here. The corona is the sun's atmosphere, so all this air and gas and charged particles all around the sun. That is our sun's atmosphere called the corona. The core is in the very center. Of course, that one's one of the easiest ones. And the sunspots are these dark spots that are on the surface of the sun. And then your solar flare is an explosion off of the surface of the sun. And the prominence is a ring or loop of hot gas that is spewing off of the surface of the sun. Okay, so this is just an easier way for us to visualize it. I know I had pictures on all the slides, but this is an easier way for us to understand exactly what we are looking at. Okay, all right, and that is your lesson on the sun.